Assalamualaikum, and we meet again. So this is the lesson for analysis on the buck boost converter. So as you can see here, okay, so this is the buck boost converter. So we have the DC source, the switch, okay, the switch here, and the inductor, the diode, capacitor, and also our V out, okay, the load. Okay, so in this lesson, we will actually derive the equation between the output voltage and the input voltage. So actually for the buck boost converter, the output is related to this equation, minus D1 minus over 1 minus D VDC. Okay, so as you can see, we have this minus. So actually buck boost converter, it actually, as the name reflect, so it can be a buck converter, it can be a boost converter depending on the duty cycle. So if the duty cycle is less than 0.5, so it will be a buck converter. And if D is larger than 0.5, so it will be a boost converter. Okay, and if D is 0.5, so what happened? So if you substitute 0.5, D is equal to 0.5, you will see that the V out will be unity. It's actually just a negative. It will be actually equal to the voltage source. Okay, so our lesson today is actually how to derive this relationship. So based on the boost and also the buck converter that we have already learned, it is the same step. So what you need to do is to analyze the circuit under two conditions. The first one is the switch on and switch off. So we go for the switch on first. What happened to the circuit when the switch is on? So we consider this one will be turned on, close. So okay, so definitely this one will be more positive compared to this. Okay, so meaning that this diode will actually reverse bias, so the current will actually flow inside the inductor, so it will charge the inductor. So my KVL here will be a very simple one, which is negative VDC plus VL, so equal to 0. And we know that VL is L di dt. So we arrange to this one will be DC. And this one, I just put delta IL on over dt. So this one will be VDC over L. And finally, I will obtain my equation delta IL on is actually VDC over L multiplied with dt. So this is the equation, okay, for switch on. And then we move to the condition when the switch is off. Okay, so what happened when the switch is off? So when the switch is off, meaning that switch is open. So the DC source right now is disconnected from the circuit. So right now the energy will come from the inductor. So the inductor will discharge and flow through the load and go back to the diode. So meaning that this diode will actually turn on. Okay, and we can actually represent as a short circuit. So based on this KVL, based on this circuit, so the KVL on this circuit is we have okay, the KVL for when the switch is off is actually positive VL minus V out equal to 0. So we will have VL is equal to V out, and we can write down this as DIL over dt is equal to V out. So delta IL off over delta T is actually during T off. So we can just write down 1 minus T. T is equal to V out over L. Okay, so we will have delta IL off is equal to V out over L multiplied 1 minus T. Okay, so we have this equation. Okay, delta IL on and delta IL off, and okay, and then so based on the steady state operation, okay, so please be noted, this is only the magnitude, okay, no sign. Delta IL on must equal to the magnitude of delta IL off, or in other way I can say that delta IL on is minus delta IL off must equal to 0. So this is actually applied for buck converter and also boost converter. If okay, please correct me. Okay, should be only the magnitude. Okay, so delta IL on should be VDC over DT. VDC over L DT. Okay, minus the magnitude only, which is V out L 1 minus DT. Okay, should be equal to 0. Finally, we will have V out is equal to negative D1 minus dV dc. Okay, so that is the relationship between the buck boost converter, and as you note, this DC source, okay, VDC is not directly connected to the load. Okay, as you can see during the switch on also, with the source is actually, the energy from the source is actually stored by the inductor. Okay, so because so the source is directly not connected to the load. Okay, during switch on, during switch off also, the DC source is not connected to the load. So all the source is come from the inductor itself. So meaning that the inductor is actually the source for the energy for the load.